Hello, my name is Peter Sabala, and this is my Physics 2211 Lab 3 presentation. As an intro, the purpose of this lab is to use the universal law of gravitation to find the mass of a black hole and to model the effects of celestial bodies on motion. In part 1 of this lab, we'll be finding the mass of a black hole by modeling the effects of its force on the motion of a star orbiting around it, and in part 2, we'll be finding the initial velocity needed for a spaceship to launch off of a moon and orbit around the moon and a planet in a system without crashing. The system for part 1 of this lab is the star and the black hole, and for part 2 it is the planet, moon, and spaceship. And in the surroundings for parts 1 and 2, the surroundings are basically just everything else in the universe besides those things. Some important formulas for this lab that we're going to be using is Newton's second law. We have F net is equal to force of the parallel force plus the perpendicular force. And then we need some momentum and impulse formulas in order to make our glow script code in order to model the motion. And then I think the most important formula for this lab is the universal gravitation formula. And that is the universal gravitation constant times the masses of the object divided by their radius squared. That's the force of the attraction between the two. For part 1, we're going to have our star orbiting around the black hole, and our goal is to determine the mass of the black hole, and this is kind of the main chunk of code that we'll be using. And you can kind of see we have the F net equals the perpendicular force times the parallel force, and then we have our universal gravitation formula in order to make that code. And at the very end, I guess it's not at the bottom here, but I just averaged all the data points between the code calculates the force at each point around the black hole, and I just had that average all of those in order to find the average mass of the black hole. And that came out to be this number here. On to the what does it mean question for this lab. Basically, this question is asking how the net force and its parallel and perpendicular components are different from the rate of change of momentum and its parallel and perpendicular forces. So basically, your net force and dp dt, which is the rate of change, are mathematically the same because they both equal universal law of gravitation. However, the net force is just an instantaneous force, while the dp dt is an integral, so it's going to be over each time step. And so as the interval of the time step increases, that data can become less accurate. So that's kind of how those two are going to be different. Part 2, we're going to determine the velocity that the spaceship needs to orbit around a planet and a moon. I'll show you guys a video of this code in a second, but again, we can kind of see our formulas in play here with our universal gravitation and parallel forces. This time we need multiple universal gravitation considerations because it's both the planet and the moon acting on the spaceship, and I determined that the speed needed to be -26 in the x direction and 101 in the y direction to model this, and I can show you that right here. And you can see that our purple dot here, the spaceship, is kind of orbiting around this planet, and both of them are on the moon, and it's still taking the effect of this planet here as they both orbit around the planet. So that's kind of how that came to be. And what if there was a black hole, a planet, a star, and a moon in a system? So I guess the answer to this question, there would be 6 different gravitational forces because you have the black hole and the star, planet, moon, the planet on the star and the moon, and the star and the moon, and vice versa. All those are acting on each other. And then I think there would be some dominant interactions if there's different masses or radiuses between the objects that could, cause some forces to be more dominant than others. Some possible errors is for part 2, I just used trial and error to find the velocity which means that different answers could be correct to find the different orbits that fit the prompt. And then also because the calculation used for this was an integral and it was a time step, if the time step had been too large, then it might not be completely accurate. And that's my Physics 2211 Lab 3. Thank you.